Hello, everybody. Today we are going to make a crowdfunding smart contract on the day 9 of our Smart 25 Days Challenge. And crowdfunding is basically a platform where the users would be able to create their campaigns, their crowdfunding campaigns, and other users would be able to donate to that specific campaign. So, in our smart contract, we would try to make a smart contract which will allow the multiple users to create multiple crowdfunding campaigns. And how we are going to do it is a step by step process, and I will take you through it. So, first of all, let us make a crowdfunding smart contract, crowdfunding.solve. So, let's start making it. The first line is always our SPDX license identifier and then Pragma Solidarity. So, now let us start coding our smart contract. The contract name would be crowdfunding only. So till now we have seen the use of structs, modifiers, mappings, and functions. In this smart contract, we are going to use them all at one place. And in this smart contract, we'd see the use of all of them. And this is going to be a great smart contract from the purpose of learning. And we would be learning a lot from this smart contract. So what we are going to do is for each campaign we are going to create a struct, and that struct would handle the details about a specific campaign. And for donations also we'll make a struct which will keep track of the donators who donated to a specific campaign, and that would be helpful for us to display all the donors who have donated to a particular campaign. We will allow that anyone should be able to view the donors of a particular campaign, and for each campaign the list of donors would be available, and the funding given by them should also be made public so that it would increase the transparency, and we want that in our smart contract. So let us first of all create a struct for keeping the contributions, struct which would be called contribution, and this struct will have two properties: event amount and a boolean flag that is exists. And I will explain why I am using it when we'll go to its the usage of this struct in our functions. So let us now create another struct called campaign for keeping the campaign data, and this struct will have the properties such as name, the description of the campaign, and the creator about this campaign, who created this campaign. And along with that we'll also keep a minimum donation amount so that any user would be able to know what is the minimum permissible amount that could be donated to this to this campaign. And that's it. And other than that we'll also keep the properties such as the goal and the deadline. What is the deadline by which the user wants the funds to collect the funds? So let's make that. And then address of the creator, and that address would be payable. Why we want the address to be payable? So that it should be able to receive the funds. Deadline, then minimum donation, then to know the total contributions. Other than this, I guess, yes, is the goal achieved, reached, that goal project complete, and whether the funds have been withdrawn. Along with this, we'll also make a mapping in this struct itself. That mapping will associate the addresses with the contribution struct, know about the contributions made by uh, each address. Let us call this mapping contributions, small c, to differentiate it, and without this is with s, yes, and this contribution is a single struct with capital C and without any s contribution. So and that's it for the mapping, and that's it for this struct campaign. After this, let us in this smart contract we'll also use the events, and how we are going to use them is that we'll make two events. That is, first of all would be that the goal has been reached, that yes, the funding goal has been reached, and the other event would be the project has been completed. So why we are doing so is to notify the external users, or to notify our front end that yes, this campaign has now received the sufficient funds, and now the goal has been achieved and the project is complete. So that the events are helpful. I have already told you in detail about the events. If you don't know, then please watch my previous videos. So let us now make another mapping to associate mapping to associate events with campaigns, so that we can actually label each campaign. So we are associating a event with this campaign struct, and let us make that mapping as public and call this campaigns. So that's it. And to associate for this event, how we are going to do it is we are making uh, a event public variable called as campaign counter, and it will keep track of it will assign associate the event number, that is say index. You can assume that to be a something like an index, and that would assign events events to these campaign structs, so that each campaign could be identified separately, individually, and that's the purpose of this mapping. And how we are going to do is in the following manner. So counter, and now let us make the events also, which I was talking about. Event. And one more thing, if you have noticed, now in this smart contract I am not using event 256, and instead of that I am using just uint. Why is it so? Is that uint and uint 256 are the same thing only. I have told you before also, And for shorthand notation, I am using this uint only because we would be using it so many times in this smart contract. So today I am not using uint 256, and it depends on your preference also. So I am showing you that uint 256 and uint are the same thing. And for more detail, you can watch my previous videos. I have told you about uint 32 also, and how these bits make a difference. So let us get back to our smart contract contributions. Okay, looks fine. Then another event would be that the project has been completed. So project complete. Unit ID campaign. Yeah, and then campaign ID and goal reached. So after this, now let us also use a modifier, and that modifier will help us. So as I've told you earlier also, modifiers are used to create specific checks, and this modifier will help us to help us with redundancy, so that we may not write a particular check again and again. So if you don't know about modifiers, then please watch my previous videos. Only let us call this modifier only creator. Yeah, and can require require that the message dot sender should be the creator. Message dot sender double equals to hence banks unless can id dot creator. So Uh, if this is not true, then we'll show the error messages. Only the creator can call this function. After this, we'll keep a underscore. And what this require statement is doing, this I'll explain you in a bit, and then only it will be more clear. So let us first make the function to create a campaign. String memory name string memory description you will go you will. So I have basically told why we use memory keyword in string parameters and not in uint. So I have told you before only, and just for a simple reason. So what happens is it will show a error that the data location can only be specified for array, struct, or mapping types, but memory was given. So it does not allow us to give the data location for uint types, and for memory for string it's required. And To go in more details, it is a matter of pass by value and pass by reference, and we'll not cover it here. We'll, if you guys have any confusion regarding that, then I'll create a separate video regarding that. But for now, you can understand that for string parameters, we use the memory keyword. And let's get back to creating our function. Let us complete our function. So unit duration in days, unit minimum duration. Let us make it public only. Now what we'll do is we'll create a unit variable called as campaign id and give it the value of the campaign counter. So tell me at this time what would be the value of this campaign counter. So as we have not initialized it with any value, it gets initialized with a default value, and for the default value for units is 0. So currently the campaign counter is set to be 0, and now the campaign id becomes 0. So let us create a local reference variable for the campaigns mapping called as campaign equals to id. So in this line, what we are doing is we are retrieving the value of this from the campaigns mapping. Okay, this mapping we have created just now, campaigns mapping, and we are retrieving the campaign struct associated with this campaign id. Okay, this campaign id means 0 at this present time. So what is campaign struct is associated with 0? It is basically campaign struct with all the default values, because till now we have not yet initialized it, or we have not yet given the values to the campaign struct associated with the 0 value. Like the campaign id currently is 0, because just now I told you that the campaign counter is set to be 0, because the default value is 0 for units. So now the campaign id is 0, and here what we are doing is we are actually creating a local reference variable. Reference variable means that that is why we have used this storage keyword, and this storage keyword means that we want to change the state of the of the data stored at this place. Okay, and what is stored at this place? This place means that in the campaigns mapping at the we have associated this unit with some campaign struct. Okay, in the campaigns mapping, what we have done is we have created a mapping in which the unit is being associated with the campaign structs. Okay, and at this very moment when the campaign id is 0, so in the campaigns is mapping, when the campaign this unit is 0, so what value this key is 0. Okay, currently, and the value of the campaign struct, what value would be received would be the campaign struct with all the default values. Default values means for a string it would be an empty string, for unit it would be 0. And why we want that? Because we want to give associate we want to give the values, we want to change the default values which would be retrieved from here to the values which the user will provide, and user will provide these values. That is why we have taken in the function parameters, that would be the name. So we want will change the name of the from the default value to the name provided by the user. And for that, what we have done is we have created a local reference variable. And this is a reference variable because it is actually pointing to a storage location, and that storage location would be and we would be changing the state of that storage location, the state of the data stored at that storage location. Okay, what we have received just now. So now let us do it. So now we can access the properties of this struct. Okay, this struct by using this local name. Okay, this is the local variable name, reference variable name, which we have just now created, and now we'll be able to access the properties of this struct, and the properties are name, description, and all. And now let us assign the values to these properties. So the message dot sender becomes the creator because he is calling the create campaign function. So similarly, the description provided by him becomes the we assign that uh, assign this value to the description property, okay, of the struct. And I hope I am clear, but still, if you guys have any problem or any doubt, then please ask me out in the comment section. Campaign code is the user will provide, and this goal we would be multiplying it with 1 ether because we want the goal to be in ethers. If you want, you can change the name of the variable here so that the user would be while specifying that the user would be clear that I have to specify the goal in ether. Okay, ether, if you want, you can. So goal in ether. So while specifying only, just as we have done in duration in days. So while calling this function create campaign, the user would be knowing that, okay, I have to enter the goal. The amount, the value which I am entering, 123, is actually the number of ethers. Okay, so he may not think that he may not remain in some confusion that what the value is, is the value is in way or is in ether or what. So that's why we have now specified it, that goal in ether, and we are giving this value to the goal property of the campaign struct. So let's move to block the timestamp, because at the time when the function is called, the block dot timestamp plus duration is into 1 days. Simple. So this ether, so now we have converted that goal in ether. So the goal to be in ethers, and similarly now we have converted the value given by the user to the number of days by multiplying it with days and adding the block dot timestamp. So block dot timestamp I have told you before also. Okay, so you can go my to my previous videos if you are not able to understand any concept. Okay, minimum donation, we'll give it minimum donation is 2 ether. And let us increase the campaign counter. Campaign, campaign counter plus plus. It will increase the campaign counter by 1. Okay, so looks like the okay, so I missed a semicolon here. No, it looks fine. Okay, so now let us create our another function that would be the function to contribute, and this function will take the campaign ID of the campaign which the user which anyone wants to donate, and this function should be payable. It should be able to receive the funds. Okay, so I've told you why payable keyword is used before also. It is used to make sure that the function is able to receive the funds. Okay, and so that our smart contract would be able to receive the funds by through this function contribute. Okay, so now let us complete this function, and for this function also we'll create a local reference variable or campaign from the campaigns mapping only. So there is a difference between this line and this line, if you have noticed. Okay, so in this line we were actually creating a campaign, and we called what we retrieved was a default a struct, a campaign struct with all the default values, and then we assigned these properties some values. Okay, so these are all the properties, and this struct the value of the struct received from this line was the struct the campaign struct with all the default values, and we assigned the values to those properties. Okay, to we changed those default properties to some values which the user provided. But here what we are doing is this campaign id. Okay, this underscore I have this makes sure to use this make sure you use these underscores to specifically mention that this is the function parameter. Okay, because we have used the campaign id here also to differentiate it, that this is a function parameter and this is actually a variable. So that's why we use these underscores, and what this signifies here is the value of this struct, the value of the struct retrieved from here would actually contain some values. This struct would not be a struct with some default values. Okay, because here what is going to happen is we would have already created some struct and assigned the values, and that is why these two lines are very different. Okay, here we were getting a struct with some default values, and then we were assigning the values to those default values. We were changing those default values, to be precise. We were changing those default values to some user provided values. And here what is happening, we are retrieving the struct with some which is already in existence, and by providing the campaign ID. Okay, and here also, if you will provide the campaign ID of, say, there are only 5 campaigns, and you provide a campaign ID 6 or 7, so that will result in a that will result in a struct, the campaign struct, uh, with all the default values. Okay, so that will retrieve a campaign struct with all the default values, and I will show it to you to be more clear what I am trying to say here. Okay, so let us just first of all complete this function. We want to make sure that the campaign is not, the project is not complete, the campaign is not yet completed. I have told in my previous videos why we know use the not here, and I'm not going to repeat it once more. I have told it enough times in my previous videos. So if you guys have any problem with this, or you are not able to understand it, then please go through my previous videos. So that the campaign should have some time remaining. Block the timestamp should be less than the campaign deadline. Okay. Otherwise, you'll say that the crowdfunding is the already complete, or the crowdfunding deadline has been passed. Has passed. Looks good. Another required statement would be message not value should be less, there should be greater than or equal to the campaign dot minimum donation amount. Okay, so to check that the value which the user is sending with this function should be greater than the specified minimum donation amount. Okay, we can say the contribution should be greater than the specified minimum amount. Oh, amount. Okay, so we'll also keep one more check to check that, say, if the required amount was 5 ETH, and after collecting some funds, the campaign has managed to collect about 4 ETH. Okay, so now only 1 ETH is remaining to reach the desired goal. So now if some user wants to donate to this campaign, he should not be able to donate more than 1 ETH. Okay, so that the campaign may not receive more than the funds which it was originally required. So and the other user should be aware that, okay, the campaign only requires 1 ETH, so I would be donating only one more ETH to help this campaign reach its desired goal. Okay, so it should not be the case that the user is now some user comes and if he without any check, he if he wants to donate 5 ETH and maybe the required amount to reach the desired goal was only 1 ETH. But say if some other user wants to give 5 ETH, or she should not be able. So he or she should be notified that the amount which you are sending is greater than the remaining amount to reach to the uh, goal of this crowdfunding. Okay, remaining amount. Okay, so first let us calculate the remaining uh, amount. Campaign dot goal minus the total contributions received so far. Okay, campaign, and then we'll check the message dot value should be less than the remaining amount. The contribution amount which you are sending is greater the amount required to reach the goal. Okay, reach the goal. So that's it. So after we have made the necessary change checks, we have specified these required conditions. Now let us make this contribution happen, and how we are going to do is contribution storage. We are creating a local variable, a local reference variable of the this contribution type. Okay, contribution storage, and let us name this local variable as contribution only, small contribution. मतलब it means that small c. Okay, contribution. Mm, yes. So if the contribution is already existing, the what we are trying to do here is we are making sure that each contributor gets assigned to this mapping. Okay, so each address which donates gets associated to this mapping in which the addresses are associated with their contribution. And for that, what we are trying to do here is that if the contribution is already existing, okay, so then we'll not pass the array. Say if there is a particular user who have donated to a campaign and that campaign was requiring 10 ETH in the beginning. Okay, so after collecting some funds, this campaign now requires 2 more ETH, and there is a user which had donated to this campaign earlier. Maybe he had donated 1 or 2 ETH. Okay, so after some time he saw that the goal of this campaign has not yet reached, and maybe he may think ki, okay, let us now donate 1 more ETH or 2 more ETH to help this campaign reach its desired goal. So this what we are keeping this check helps us ensure that user should not be added again and again, so that the redundancy should not be there. Okay, so even if the user may donate 2 or 3 times to a same campaign, his address should not be repeated in the donators array in the so that we may know that all the donators and the single donator should not be repeated again and again. Okay, so the contributions, each contribution should be accounted for, and then that user's contribution amount should be increased from one ETH which he had donated earlier to two or one more ETH whichever he may want to donate now. So that is why we are keeping this check here. Okay, contribution dot exists and um, if it is so now we'll set it to true. If it the contribution dot exists was false, so this not will make it true. And now we will make sure that okay, if the contribution was not existing earlier, we will make sure to make it true that now yes, the contribution now exists, and we'll add the address of that donator to our donor addresses. This, where is it? Okay, so I actually forgot to add the donor addresses array in the beginning only while defining this struct, this campaign struct. We also, as I told you earlier, also we also want to make sure that uh, everybody would be able to know that the donators, who are the donators for a particular campaign. Okay, so we are keeping all the addresses of those donators into a donor addresses array. So the array of addresses which will contain the donor's address, and then now we'll add the donator's address, the contributor's address if it is not existing. Okay, so now what we are doing is campaign dot donor addresses dot push message dot sender. Contribution dot amount is increased with message dot value, and campaign. This contribution dot amount means the contribution made by a particular donor. Okay, so that's what I was talking about. Say if a donor has donated 2 ETH or 1 ETH, say 1 ETH. He has donated 1 ETH in the beginning of a campaign, and after some time he saw that this campaign which he had donated earlier to is still not able to reach the goal, and he want to donate some more ETH. Okay, so now let us say he wants to donate 2 more ETH to this campaign. So his total contribution amount should be increased. Okay, so this contribution dot amount here signifies the contribution made by the particular that particular donor. Okay, that particular contributor, and that's it. And what is happening here is after this we have added the message dot value to the contribution amount. We also want to we also want to increase the total contribution to this campaign. Okay, because we want to keep track of the funds received by a particular campaign. Okay, so let us do this. Campaign dot donor addresses dot, oh sorry, not donor addresses, campaign dot total contributions, campaign dot total contributions plus equals to message dot value. Yes. So what we are doing here is that we want that if the total contribution is now exceeding or equals to the campaign dot goal, and till now we have, if we have not made this is goal reached, okay, is goal reached flag as true. So what we are going to do is we're going to make it true here, and then we'll emit the event that yes, the goal has been reached. Becomes true. Emit the event that funding goal reach this, and the campaign ID should be campaign ID, and the total contribution should be the campaign dot total contributions. Okay, that closing bracket was extra there, and now this function looks good. This function is now complete. So now after making the contribute function, let us make the complete project function too. What this will help is that, say, if the funding goal has, if the crowdfunding attained its desired goal without the deadline being crossed, okay, so the deadline has not been arrived, and say the crowdfunding which was required to collect 5 ETH has managed to do so before its deadline. So the fundraiser, the creator of the funding of the campaign, should be able to mark the project as complete, that yes, my project has been complete, and allow me to withdraw my funds. Another case could be that, say the deadline has passed and the crowdfunding has not yet managed to get the desired funds, so but it has managed to get some funds. So in that case also, the creator of the campaign should be allowed to withdraw the funds which the crowdfunding has managed to collect, so that at least he may get some help. Okay, so it is better to get some help than no help at all. Okay, so that's why we are making this complete project function also, to allow the creator to mark his project as complete and then to withdraw his funds. Either the block timestamp should have passed the deadline, or so this is the symbol for or. Total contribution should be greater or equal to campaign.org. Okay, so otherwise it would show the error that the crowdfunding deadline has not yet passed, or the funds the funding goal had not been achieved. Okay, looks fine. So this will check either the crowdfunding deadline should have passed, otherwise the total contribution should have reached the specified goal. Okay. Oh, sorry. So after this required condition, we'll check one more condition. Uh, no, I don't think we need to check another condition here. That this condition would be sufficient, and we'll now, if the checks pass, we'll now make sure that this condition, this campaign is marked as this project complete. Yes, the project has been complete. This is project complete. Okay, so we are making this boolean flag as true. So that's it for this function, and we'll just do one more thing. We'll emit the event. Okay, project complete, and we'll say campaign ID, and is goal reached as campaign dot is goal reached. Okay, it was taking two parameters, campaign ID and is goal reached, and we have notified that yes, the campaign ID is the campaign ID of the campaign. Okay, and the is goal reached is should be the campaign dot is goal reached. That is true in this case, and that's it for this function. And now let us allow the user to withdraw the funds. Function withdraw campaign ID public. Only creator should be able to call this campaign ID. Looks good. And copy paste this and access it. Let us do some required conditions that yes, the project should have been completed, the project should have marked completed, and the funds should not have been withdrawn. Otherwise, the user would be able to withdraw the funds again and again. If we'll keep only a single check that yes, if the project has been completed, and say the smart contract would be having sufficient balance. Say if there are 10 crowdfunding campaigns going on, and each funding is able to secure some funds, so those funds will first come to the smart contract, and say one of the campaigns achieves its goal, and the owner marks that project as complete. Okay, so after marking that project as complete, if we'll only keep one check here before for withdrawing the funds, that yes, the project should have been completed. So what will happen is the user would be able to take the funds of other crowdfundings also, because we have if we'll keep only one check, that is that the project is complete. So yes, technically when the project is complete, he should be allowed to withdraw the funds, and the smart contract will allow to withdraw the funds again and again. So that is why we would keep two require conditions. One would check that yes, whether you have marked your campaign as true, the campaign as complete or not, and the other would be whether you have already withdrawn your funds for this campaign or not. Project has completed yet, and the other required condition would be the fund should not have been withdrawn. Funds have, let's make this capital, have already been on this campaign. So looks good. And after this only, we would first of all make the funds withdrawn to be true. That yes, the funds withdrawn has been true. No, first we should allow the user to retrieve the funds. campaign dot total contributions, and then we'll make funds withdrawn to be true, that yes, the funds have been withdrawn. So that's it for this funds withdraw funds function. And now let us make some other functions, such as to get the contribution amount for each specific donor. Okay, so now what we are going to do is to create a function which would be able to tell for a particular campaign, say for the campaign ID 0, a particular donor I have donated how much amount. Okay, so that would be to increase the transparency, get contribution amount, and this will take only two parameters. That would be, yeah, UN, oh sorry, UN campaign ID and address of the contributor. And this is only a public view function, and silent campaign ID dot contributions contributions contributor dot returns. Hmm, looks fine. So this is a long line, and I hope you would have been able to decode it. What its meaning is, that, say, first of all, let us decode this contributions contributor dot amount. What it is doing is, it is checking in this contributions mapping. Okay, in this contributions mapping, which associates the addresses with contribution, this mapping is trying to retrieve the value by providing this contributor as key. Okay, this address as the key, it is trying to retrieve a value. Okay, and that value would be the contribution struct associated with that particular address. Which particular address? The address of the contributor, which we are talking about just now. Okay, so this address underscore contribution contributor means the address of the contributor which we want to know about. Okay, and this contributions, this thing underscore contributor is retrieving the contribution struct associated with that particular address. So now let us move on to our another function, that would be a function to get the campaign details. Okay, so although the campaign's mapping is marked as public, but we are also specifically creating a function, get a function to get the details of our specific campaign details unit. Public view returns string memory, string memory address, unit, unit 1 2 then 3 4 5 and this is okay. Campaigns, then it will return campaign dot name campaign dot description campaign dot code campaign dot code. Okay, campaign dot deadline, campaign dot total contributions, campaign dot is goal reached, project complete. That's it. And okay, so the error is different number. Okay. So, okay. So, yes, it's only 3 units are required. Okay, yes, because these two are bools and 3 units, then address and string. These two string. Okay, good. Looks good. So now we have made this all these functions till now, and I hope you must have learned something from these functions, and by creating these functions you must have learned some concepts. Now let us get on to our last one or two remaining functions. That would be, till now we have created a function to get the details about the campaign and all, but now what we'll do is, for a specific uh, campaign, we would be allowing anybody to view the addresses of the donors. turn campaign dot. That's it. So just one more function to tell the user about the current time, and so that he may know that okay, how much time gets is remaining for the specific campaign to get over. So that would be just returning back the log dot timestamp. That's it, I guess. So looks good, guys. I think our smart contract for the crowdfunding is complete. So let us try to compile it and run it. Okay, so it is compiled. Let's first deploy it. Okay. So see, these are the functions, and you can test it out yourself. So first, let us try it out here only. So first of all, let me create a crowdfunding. So let us call this test one. Description just testing. Goal in ether say 5 ETH. Duration is 2 days. Minimum donation amount say 1 ETH. Let's click on transact and see what happens. Okay, so now you can click on campaign counter and see it shows one, that the number of campaigns are currently one. Previously it must be it was zero, and yeah, now it has become one. So I forgot to show you previously, but it was one only. Let's deploy it again to be more sure. Okay, so see, the campaign counter is zero. And so I told you one thing, that if the campaign has not been created and if the user in this line, okay, so this line retrieves the the campaign from the campaign ID. This line tries to retrieve the campaign struct. Okay, and I told you, if the campaign struct has not been made yet. Okay, so in this line we were what we were doing is we were retrieving the struct with default values and then assigning actually changing those default values to the user provided values. Okay, so I was talking about this only na. So if the campaign has not yet associated with any campaign ID, so what happens is a default array, these campaign struct with default values gets initialized or gets returned to the user. Say in these campaigns, if someone wants to know about say campaign number 2, so all the values are default values only. So at 0th place, say all the values are default values only. And now when the user will try to create a campaign, when the first campaign would be created. Okay, so currently the campaign counter is 0, you can see, and say the first campaign is now being created, and let us try to create that. And test one, just testing the smart contract. Only Thursday 10. Duration it is 5. Minimum duration 1. Let us try to do it. Okay. So now what will happen is, so all these values, where the default values would be changed by these user provided values, and now you can see the campaign counter is set to 1 because one campaign has been created. And at 0th place, okay, you can see the values are now these values and not the default values. So That's what I was talking about when I was saying that in this place, it can be the case, it can also happen that when the user tries to contribute uh, to a crowdfunding which has not been made, then it will retrieve the camp the campaign struct with the default values. And in that case, what will happen is, say if the user wants to donate to a crowdfunding tool which is not yet created, okay, and if the user wants to donate some, say 4 ETH, okay, 4 ETH. So what error message will come? Let's see. So the error message would be the crowdfunding deadline has passed. Why is it showing this? Because of the default crowdfunding, because of the default values of the campaign struct. See, at when am providing the value 2 in the UN 256, say, so these are the values, okay. So these are all default values, and for this you'll see the deadline is 0. So the block dot timestamp is always greater than 0. That is why it was showing 0. It was showing, so not 0, it was showing that the crowdfunding deadline has passed, okay. So if the user now tries to donate to our crowdfunding which we have just created, this crowdfunding test one, if the user tries to contribute to that, let us see what happens. If he tries to donate, say 2 ETH to it, so he would be able to successfully contribute, okay. So you can check in our uh, by entering the zero value here. You can see that in our campaign you can see that the goal is for 10 ETH, and the deadline is this in block dot timestamp terms, that when the block dot timestamp would become this, that is the deadline, and minimum donation is 1 ETH, and the total contributions till now is 2 ETH. You can see goal reach is false and project complete is false. Let us see what happens when the goal reaches, okay. Say someone donated 8 ETH to this crowdfunding. So what will happen is the balance of the smart contract becomes 10, and then this campaign has now, you can see that yes, the goal has been reached, true, but the project is not yet complete. Why is it not yet complete? Because the user will tell that okay, even though my deadline has not yet passed, but when the amount which I desired has reached, so I will make this I will mark this project as complete, that yes, the crowdfunding campaign has now been completed, and now I want to withdraw my funds, because without marking my project as complete, I would not be able to withdraw my funds, okay. So let us see what happens when the donor only, okay, say when the donor only tries to mark this campaign as complete, it will show the error that only the creator can call this function because of this modifier. Which modifier? Which we created, only owner, okay, only creator. And this line I told you, that message.sender, I will explain it to you after some time. So what this line means is that the message.sender, the person calling this function, okay, whichever function, not this function, not contribute, this complete project function, because only with this complete project function and this withdraw funds function we have used this only creator modifier. So these functions should only be called by the creator. And how we are checking that is, we are placing these functions here. So the concept of a modifier is, I have told you before only, that this in place of this underscore, the functions code gets placed, and which functions code, the function with which we are using the particular modifier. Okay, so this message dot sender means that the person calling this function should be the creator. Okay, so this creator, what is happening is that this campaigns is the name of the mappings, as I have told you. These campaigns mapping is, they are trying, this is the key campaign id, and the key campaign id is retrieving the campaign struct, इसके the campaign struct associated with the particular campaign id. Okay, the campaign id, and then this dot creator is accessing the creator property of the particular campaign struct. So this creator property is here. Okay, so I guess I am clear, and let us say now the user, the owner, marks this project as complete. Okay, so this gets executed, and now he wants to withdraw the funds, so he would be able to successfully withdraw those funds. uh, Now one more thing which I would like to mention here is that you may have noticed that this withdraw funds is not marked as payable. Okay, so why is it so? And this, the creator is able to withdraw the funds. So the reason for this is pretty simple, that this withdraw funds is not receiving the ether. Okay, the payable keyword is used when we want the function to receive some ether. Okay, and this withdraw funds is actually not receiving any ether. What is happening is, we want the message dot sender, that is why we have made this address as payable. We want this address to receive the funds. So this address, the creator's address, would be able to receive the funds. So this function, when this function gets called, this function is not actually receiving some value. Okay, so we are not providing some value, and even if we try to, then it will show some error, it will not receive some value. But the function contribute, okay, the contribute function is marked as payable because it is receiving some ethers, and okay, and it is bringing some balance to the smart contract. So that is why, without even being marked as payable, this withdraw funds function works correctly, because what we want is, we want the funds to get transferred to the address of the creator. And that's all from this smart contract. And if you want to check that the campaign details, okay, you can check by entering the value. So you will get the campaign details, and if you want to get to know about details of a particular contributor, that how much he has contributed, you can just enter for which campaign you want to know, and then the address of the contributor. And where will you get the address of the contributor? From the get donators address. Just enter for which campaign you want to know the address of the donators. So these are the addresses, just two addresses, one till here, till the comma, and the second till here. So let us try to know about this person, how much he has donated to the campaign at zero its index. Let us try to know. So see, this guy has donated 8 ETH, and let us try to know about the guy, the first guy, the first person, and this has donated 2 each. Okay, so all these functions are working perfectly fine. You can try it for yourself. And that's all from my side, guys. I hope you really enjoy it, and you learned all the concepts which I have taught here. And if you guys have any problem or any doubt, then please ask me in the comment section. And thank you for watching. Bye bye.